They make solar controllers, and I have a solar controller there's in my RV, and it's awesome. It doesn't give out RF. This is your, how many years coming here? 5? Third year? Okay. And then, this gentleman's name that came before you? I think he was the president. Rick Mullen. Yeah. Yeah, Rick used to come out and to give talks, and you stepped in his place, and yeah. So thanks a lot, Ryan, for coming out. I almost forgot your name. And we are transmitting on cable channel 58 as well throughout the camp. Yeah, that's what the other camera's for. So here you go. Have fun.
I'd like to say thank you to Kristen for helping us put all this together. Woo! Couldn't do it without you. So hi again, my name's Ryan. I'm with Blue Sky Energy Solar Charge Controllers and Jenison Solar Charge Controllers. We've been in business, well, Blue Sky Energy started back in 1998 when back then it was called RV Power Products. And we pretty much brought MPPT technology to the commercial market. Now, it was out there before, I mean, NASA was using it and stuff like that. But back in the day, nobody had maximum power point tracking controllers. Later, we renamed ourselves as Blue Sky Energy because we wanted to put it on sailboats as well, not just on the RV market. So today's pretty much a general discussion, and I try to keep it a little bit informal. So if you guys have any questions, I encourage it very much. Just raise your hand, and I'll call out on you. We're going to be talking about not just our charge controllers, but generally speaking, everything in solar that you can think of. Everything from batteries and how to charge them to different charge profiles. It seems like every year I come out here, people come to me afterwards like, well, last year I got about 50% of what you said, today about 75%, and it kind of goes on and on and on as far as the retention. But there's no such thing as a silly question, and I do encourage them. A lot of times it lets me remember things I didn't bring up or any topics I didn't discuss. So it's just great, and I encourage it. Don't feel bad about raising your hand. To start off with, I'd like to talk about what is MPPT versus PWM. Now, MPPT stands for Maximum Power Point Tracking. PWM stands for Pulse Width Modulation. Now, your average solar panel, right? Let's just talk in a 12-volt panel. Of course, I would always have you reference specifications whenever you match it up to your controller, because it gets a little confusing on the categories of panels, 12 volt, 24 volt, 30 volt panel, and it's got very little to do with their actual output voltage. But your classic 12 volt panel has an output voltage under load of around 18 volts, VMP, volts max power. Now a PWM style charge controller, when it's trying to charge your batteries as fast as it can, when it's in bulk mode and it's trying to raise your battery's voltage, it basically connects your solar panel directly to your battery. And by doing that, it forces your solar panel to operate at your battery's voltage. So now instead of putting out 18 volts, your solar panel is putting out about 12.5 volts. So you're losing 20 or 30% of your power just because you're not operating your panel at its correct voltage. Now a maximum power point tracking or MPPT controller will operate your panel at its ideal voltage, and then it does a buck type energy conversion. It's lowering the voltage but increasing the current at the same time. So for example, if you had 10 amps coming in at 18 volts, you'd have 13 amps coming out at 12 volts. The watts are the same, you're just maximizing your power. This gets more and more crucially important as you get to the higher wattage panels. Now right around 200 watts, panels tend to increase their voltage. You have your 60 cell panels, your 72 cell panels, and on and on. And their output voltage can go all the way up to 36, 37, 40 volts. And so that gets even more crucially important, because if you've got a panel that's potentially putting out 36 volts, and you're only operating it at 12, well, you get about a 30 or You're really handicapping yourself. Any questions on MPPT versus PWM? It's pretty straightforward, but this is how it goes. I cover a topic and ask questions. The difference in efficiency is if your panel is operating, let's say you had a classic 12 volt, I asked what the difference is as far as efficiency. Percentage wise, it depends a little bit on the environment. Now the hotter a panel is, the less voltage it will produce. Now even if you're in Arizona and you can literally, well you are in Arizona, but in Phoenix in the summertime, and you crack an egg on your panel, literally cooking it on your solar panel, that panel's output voltage is still going to be in the mid-15s. So the sun does affect it, but it doesn't affect it all the way down to the basement. So if you had good conditions like today, nice cool weather, you're talking about 30% difference on an 18-volt panel. Of course, if you have a higher voltage panel, that could be twice as efficient, 3 times as efficient, because you're going to want to operate 36 volts down to 12 volts. Now, moving on to the charging, right? Now, all of our controllers are programmable with every setting. Now, a lot of charge controllers will go, oh, this is my flooded setting. Oh, this is my AGM setting. Oh, this is my seal setting. We let you actually program all the voltages, any times, durations, everything under the sun, and so that you can actually pick what's right for your battery. We found there's actually a wide variance in preferred charge voltages from the manufacturers, even among the same battery types. A Trojan T105 wants different voltages than a DECA flooded, an East Penn battery. If you have an AGM, a full river, wants drastically different voltages than a Lifeline AGM. So instead of just going lotta, we want to choose for you. We allow you to choose all those voltages. And also lithium, of course, has a different charge profile. Talking about the stages of charging, the first stage, so when your controller wakes up, woohoo, it goes up to your absorption voltage. Now, the first set point, the absorption voltage, used to be called constant, then it was called acceptance, now it's called absorption. It's kind of like an AA meeting. So if you have your controller, your actual controller says, hey, I'm in acceptance mode, and somebody else says, hey, I'm in absorption mode, same animal, the same set point, the first set point. Now that'll range between, say, 14.3 to 14.8, depending on your battery manufacturer's recommendations and what kind of battery you have. Now it's important to get on a lead acid battery, and we'll talk about lithium a little bit later, but it's really important to get to that first stage, the absorption voltage, in order to properly desulfate your cells. Now, to put simply, when your batteries discharge, the sulfates molecules, they attach to lead plates, and that basically grows like a coral reef on your lead plates, called sulfation, particularly soft sulfation. And then as you charge your battery, that coral reef turns back into acid. And so it's really important for your particular battery to dial in their preferred voltage to make sure that that chemical reaction happens and everything turns back into acid. And that's a lot of times where people have heard, for example, you never want to let your battery become too discharged. You never want to discharge it below 12 volts, below about 60% state of charge. And that's because if that coral reef grows on that lead plate too big, it's harder to turn back into acid. You'll also hear people say, you don't want to leave your battery discharged for a long period of time. That's because the longer that sulfation or that coral reef lives on that lead plate, the harder more it crystallizes and the harder it is to turn back into acid. The next stage of charging is you drop down to the float mode, the float voltage, and that'll be 13.2 to 13.7-ish, depending on which battery you have. Now, that transition from the higher absorption voltage to the lower float voltage can really be done in 2 different ways. Now, a standalone charge controller doesn't know how much current is reaching your battery, so it's just going to choose a time, or you can program your preferred time, on how long it'll stay in that absorption phase. The ideal time varies depending on how discharged your batteries are. It could need 2 minutes in absorption, it could need 4 hours in absorption. It really depends on how discharged your batteries were, and how long they were sitting at lower discharge situation. So standalone, as an industry standard, we generally say about 2 hours is ideal. If you don't know, because we don't want to hang there too long, we don't want to hang there too small, too long. And you might say, well, why don't I just hang out at absorption all day long? Now the battery construction, if you look at a battery, you've got the lead plates, and then you got this secret sauce, everybody's industry secret, the secret recipe, around these plates, or it's like a paste that goes around these plates. And the higher you stay at that voltage, the higher absorption voltage, the more you use up or degrade that paste. And that's what eventually causes lead acid batteries to die, right? Like that's why your lead acid battery only lasts 5 years, 7 years, whatever, right? It's a combination of no more paste, or that sulfation becomes too hard to turn back into acid. Now on the other side, you want to get to that high voltage in order to desulfate the plate, to turn that coral reef back into acid. So you play this game between holding up there just long enough but not too long. So other than standalone time, I'm going to get to the absorption phase, I'm going to go there for 2 hours, then I'm going to drop down to float. The other way to base that transition is on the net current reaching the battery. Now we have you do this by utilizing an external current shunt between your battery bank and everybody else, between all loads and charge sources. So I often tell people on how to install it, I'll say, well, put your finger in every negative of every battery. The only thing touching that finger should be another battery or the shunt. with the only caveat temperature sensors. Now, we do have a current shunt. It's utilized with our IPN Pro remote. And so now the controller, well, if your battery is at 14.4 volts-ish absorption phase, and your resting voltage of your battery is like 12.8, it's always going to take some amount of power to keep your battery at that higher voltage. So eventually that amount of power to keep it at that higher voltage becomes redundant, right? They use that power for no reason. So a lot of battery manufacturers will specify how much power is that when it becomes redundant. Our factory default is about 1.5 amps per 100 amp hours of capacity. You know, Full River, I believe, specifies 2 amps per 100. Lifeline specifies 0.5 amps per 100. You know, so it does vary on what each manufacturer's, you know, their float transition set point could be. But that works good in two ways when you base it on the current. Now your controller wakes up, woohoo, goes the absorption voltage. Now if your batteries are fully charged, it's going to go, oh, you're charged, boom, I'm in float immediately. You're not holding that voltage unnecessarily long. Or reversely, if your batteries have been heavily discharged, or if you've got a lot of loads going on while holding that absorption voltage, it can hold it longer as needed, and that way it drops down to the float voltage when your batteries are actually perfectly fully charged. And this greatly increases your battery's longevity. Another thing to increase your battery's longevity, I always recommend with lead acid batteries, a battery temperature sensor. They're not very expensive, like 30 bucks, because batteries like to be charged at slightly higher or slightly lower voltages depending on how hot or cold they are. The colder the battery, the higher voltage it wants. The warmer, the reverse, you know, the lower voltages wants. And for a small investment, you can easily increase your battery's longevity by quite a bit. And of course, if everybody lives in Southern California and it's beautiful San Diego, 77 degrees all year long, or pretty close to it feels like, it may not be as important. But if you're a desert camper, or even if you're storing your batteries in a cold environment or a hot environment, it becomes more crucially important. And it's just one of those things I do recommend it for everybody. Any questions on charge profiles? And we'll, lithium, I'll touch base on lithium for just a moment. Lithium batteries, they have a similar charge profile to lead acid batteries. Now, everybody's got their own opinion on how to charge a lithium battery, and everybody's still learning. It's a new technology, and some people will say, oh, I want two-stage CCCV and just hold at 14.6 forever. Other people will do a multi-stage charge profile, and then their precise voltages will vary depending on opinion. Of course, I have my opinion, and I'm happy to share it with you, but I don't want to tell any battery manufacturers are wrong when they're trying to charge their battery. More importantly, when you look at your standard profile versus lithium, the float voltage on a lithium battery is going to be much higher if you do decide to go in a multi-stage charge profile. It's going to be about 13.6 if you're cycling your batteries every day-ish, you know, and then it's going to be about 13.4 if you're basically going to let them sit for weeks on end in between. That's because traditionally you don't float a lithium battery. You don't want to provide current to keep its voltage maintained. So the resting voltage of a fully charged lithium battery initially would be like 13.6 volts, maybe a little higher, and that'll settle down a little over 13.4 volts after a couple weeks. So if you choose a set point beneath the voltage, then you're not actually providing current to maintain it. But you do have to pick a set point, because after you charge your lithium battery, you still want to maintain all the loads in your rig until the batteries, you know, until the sun sets, you start utilizing that power, you know, that renewable energy you made. Any questions so far? Yes, sir.
Okay, lithium batteries. The kind that lithium battle board, 12 volt, once you buy it down there, you need a specific charger for the lithium battery. It's a regular 12 volt.
He asked, you know, if I get a lithium battery, a Battleborn, a Life Blue, you know, there's Relion, there's several out there. The chemistry is the same between them. Do I need a specific charger? Well, you need a charger that is able to be programmed to, you need a charger with variable programmable settings, right? So, and that's why I'm saying, like, specifically the higher float voltage is more necessary. So if you have you have a charger that floats a battery at 13.2 and you can't alter that, then at that stage you're gonna have a hard time, because your battery is gonna discharge quite a bit before your PV starts, you know, taking up the load before the sun sets. So the charge voltage on it ranges between 14.2 to 14.6 for a lithium iron phosphate battery. So it's really similar to most absorption voltages, but the float voltage is a lot more important. Also, the time spent at the absorption phase is a lot less for lithium batteries. Now, the preferred time varies among manufacturers. I've had some manufacturers say 12 minutes is plenty, and other manufacturers say, like Battleborn, 1 hour per battery. I think that's a little excessive, but you know, that's what they want, that's what they get. I mean, if you had, I can almost live with 1 hour per you know, battery bank, but the longer you hold a lithium battery at that charge voltage, or in a lithium world they call it the balancing voltage instead of the absorption voltage, the harder it is on the cells. And so that's one of those things, like, everybody's got their opinion. I'm not going to come and say Battleborn's wrong. They make the batteries, they make a ton of batteries. You know, follow their advice, no problem. If you start reading into this, you'll find that everybody has a different opinion, slightly, on how to charge lithium batteries.
So to answer my question, Mark, in other words, a regular charger that you buy is not suitable for lithium.
Well, I mean, yes, it's like any charger you buy is not suitable. It's too much of an open-ended question. I think a lot of chargers are programmable. Maybe a lot of chargers have set points on them, like their AGM setting might be suitable for a lithium battery, even though it doesn't say lithium battery, but you'd have to look at what those settings are. A lot of times, a common AGM setting is going to have a low absorption voltage and a high float voltage in general. And so you very easily could have an off-the-market charger which is compatible. You'd have to just look at that particular charger and determine it for yourself. But in general, you want a lower absorption time and you want a higher float voltage on the lithium batteries. And of course, all of our controllers are completely programmable, so you could change any parameter you want any which way from Tuesday, and you can just, you know, have fun with it. So I can't speak for all controllers in the world, but you know, if you have any questions, I'll be happy to look at any data sheets or anything afterwards, see if I can help out and solve that answer for you. Yes, sir.
Do AGM batteries have the same sulfation problem that lead acid?
Yes. Yes, the AGM batteries have the same sulfation as lead acids. Yes, AGM battery is a lead acid battery. The difference is, instead of having the plates sitting in, you know, the juice just floating around there, they have like a sponge next to the plate. That's why you can orientate them in any direction, and they don't tend to lose water. They're all sealed environment. Now, talking a little bit about equalizing batteries, right? Because we're still in the charge profile, you know, discussion here. Now, equalizing a battery is when you bring it up to a deliberately higher voltage in order to aggressively desulfate those plates. Now, that equalization voltage could range from 15.2 to Trojan's T105's astounding 16.2 volts. Woo! I haven't talked to Trojan personally. I'm like, really? They're like, yep. I'm like, okay, no problem. You know, so of course you can, every battery manufacturer can have a different equalization voltage, and of course you can program it on our controllers, and then very often you can, you know, pick it. Now, often they say, how often should I equalize my batteries? Now, same thing, when you equalize your batteries, you are using some of that secret sauce from your plates, but you're also keeping the sulfation off the plates, so you're going like this. As a rule of thumb, as an industry standard, you pretty much say you equalize for 2 hours every 30 days if you're actively cycling your batteries. So if you're out here and you're using your batteries every day, they say about 2 hours every month is ideal. If you're a weekend warrior, of course it depends on how much you use your batteries, but you know, you might do it quarterly or biannually for a couple hours. Now, a lot of people say, can I equalize an AGM? And that's, you know, the initial answer is like, no, you can't equalize an AGM. And I'm not telling anybody to go equalize their AGM. Don't take me to the bank on this one, right? The principles of equalizing and actively, aggressively desulfating your batteries does still apply to AGMs, but with a sealed battery, there's no place for the steam to go if you get them too hot. So they can bloat and it can ruin the battery. Some battery manufacturers like Lifeline do give specifications because they actually have a little vent in their battery for reconditioning them. And they'll say, okay, you don't normally have to do it, but if you do, your batteries were severely discharged or they haven't been charged in a long period of time, fully charged in a long period of time, it can be beneficial. And they say you can go, 15.5 volts for up to 6 hours. Now, personally, when I have people, you know, do lifelines, I say I'd rather you do like a half an hour a day for 2 weeks or 1 hour a day for 6 days versus 6 hours in a day. Because if your battery accumulates that heat and you lose those electrolytes, that water out of the batteries, there's no way to get it back in there, unlike lead acid batteries. One other benefit of equalizing a lead acid battery is when they gurgle, you're mixing the acid and the water within the battery. Because the acid is heavier than the water, it tends to settle, and then you get what's called stratification of your plates. So in essence, the coral reef is only growing to the bottom and not the top.